Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 4, and we're in 4.6, Day 1 and Day 2. Day 2 is pretty short, so we're going to do it all in one video. The name of this lesson is Using the Slope-Intercept Form, and the essential question is, what is slope-intercept form, and how do we use it to graph lines? So, when I ask people what slope-intercept form, they usually know what it is from middle school. It's kind of an important equation. It's y equals what? Do you know what I'm going to fill in here? It's going to be y equals mx plus b. If you knew what it was, good job, way to go. It's a very important equation of a line that we use in Algebra 1 especially. But it's useful for all kinds of different kinds of math. So what do the different variables mean? What does m, well, what represents the slope of the line? I gave it away. It's going to equal m. M is the slope of the line. We talked about that in the last video that was, so that's not a problem. And what's the y-intercept? Which variable is the y-intercept? It's going to be the b, actually. Okay? And in order for it to be in slope-intercept form, the y must be by itself. You can see that y is all alone on the left-hand side here, or right-hand side. That would be fine too, but make sure that y is by itself for this. Also, I want you to draw right here is there is no x included in the slope. So if you had something like y equals, that's bad, 5x plus 4, the slope equals 5, not 5x. Okay? It's not 5x, it's just slope is just 5. It's whatever's in front of the x. It does not include the x. Okay? All right, sounds good. Let's go ahead and get into this then. Let's go back to our green. So it says find the slope and the y-intercept of the graph of each equation, of the equation. So, number 1, we have y equals 2/3 x plus 4. Well, we're using the formula y equals mx plus b. It's helpful to write the formula below it so you can see what matches up here. So our slope was m and our y-intercept was b. So what's our m in this case? Well, hopefully you see that matching in front of the x is going to be 2/3. And what's our b? Well, our b is going to be positive 4. That's easy as it is. That's all you got to do. If it's in y equals mx plus b form already, then it's pretty easy to find. But what's going to be a little bit challenging is now we're going to have to go back to solving equations for y, getting y by itself. That's why we're practicing it in the last couple chapters and stuff, or last couple sections. So let's review that a little bit, okay? So if I had 2 plus y equals 7, if I had something like that, how would I get y by itself? Well, I would subtract 2 from both sides, right? Well, it's the same kind of thing here. We need to get y by itself on the top here. So we have 2x plus y equals 7. So to get rid of this 2x, which is not touching the y, I'm going to subtract 2x from both sides, okay? I'm going to subtract 2x from both sides. I'm going to get y equals... Now, am I going to get 5x or negative 2x plus 7? I see some people still making the kind of, the mistake of not doing what they're supposed to here. So are these like terms right here? Are 7, can you subtract 7 and 2x? They are not like terms. This 7 does not have an x, so you actually cannot subtract them. So these have to go side by side. So the way I'm going to write this is negative 2x plus 7. And that's actually our equation. You're not going to write y equals 5x, not negative 5x. This is not the correct equation because those are not like terms. You cannot combine. Things need to have the same variable and the same exponent in order to be combined. Otherwise, they're just going to go side by side. So this is our equation right here. So this is y equals mx plus b. You don't need to write it every time if you don't want to. I'm just trying to help you visualize what goes where. So what's our slope for this one? Well, it's going to be negative 2, and our b is going to be 7. Okay, so be careful when you're subtracting stuff. Usually where these kind of problems, when you're subtracting 2x to both sides, it's just going to kind of come along for the ride over here. It's not going to kind of combine with stuff very easily. Sometimes it might, but not always. Next one we have is 2x minus 3y equals 12. We need to get that negative 3y by itself, so what will be the first step to do that? Well, we're going to subtract 2x from both sides. So we're going to get negative 3y equals, is it going to be 12 minus 2x, or is it going to be negative, so is it going to be 10x, or is it going to be negative 2x plus 12? Hopefully you said negative 2x plus 12, because they are not like terms. This one does not have an x, so you cannot combine them. Okay. Now we need to get y by itself. How do we get rid of that negative 3 in the front? It's being multiplied here. How do we undo multiplying by negative 3? Well, we divide by negative 3 on both sides. So we're going to get y equals negative 2x divided by negative 3. Those are going to, the negatives are going to cancel, but 2 does not divide by 3. So I'm just literally going to write 2/3 x. And then 12 divided by negative 3 is going to be negative 4. Do not put 0.66x like this. Okay, we want to keep the fraction because if we're graphing these kind of things, you want the fraction. It's going to be really hard to graph something that's in a weird, decimal. Okay, so this is actually our final answer. This is y equals mx plus b. So what's our slope and our y-intercept? Well, our m is going to be 2/3 and our b is going to be negative 4. All right. Cool. All right, next one, 4. Y equals 8 plus x all over 2. This one's kind of a weird one, all right? So what you need to know about fractions that have two things in the top, two terms in the top, and one denominator, is you can split them up. So I'm going to rewrite this as y equals 8 over 2 plus x over 2. Okay, now we can reduce this a little bit. What's 8 over 2 reduced to? Well, 8 over 2 goes to 4. And then x over 2, what number's in front of the x there when there's nothing in front? Well, there's going to be a 1 here, right? So I can rewrite this as 1/2 x. We like to put the fraction in front of x when we're doing these kind of problems. And then there's one more thing that's wrong with this. Do you guys see what it is? Well, we want to put the 1/2 x in front. We want y equals mx plus b. This is not wrong, but it's just kind of flipped around. So we're going to write y equals 1/2 x plus 4. All right, so what's our m, what's our b? Well, our m in front of x is going to be 1/2, not 1/2 x, just 1/2. And our b is going to be the number all by itself, the constant, which is 4. Okay. Number 5, we have 10x plus 5y minus 3 equals 0. We need to get y by itself. So you could either move 5y to this side, or you can move stuff away from 5y. I'm going to move stuff away from 5y to keep it positive, but let's go ahead and do this. So we can get rid of this 10x first, or the negative 3 first. I usually like to move constants first. So I'm going to undo subtracting 3, what am I going to do? I'm going to add 3 to both sides. And then to keep the rest of it the same, 10x plus 5y equals 3. Okay, and then we need to still get the 5y by itself. So how do we move this 10x to this side? Well, we're going to either add or subtract. It's positive, so we're going to subtract 10x from both sides. So we're going to get 5y equals negative 10x plus 3. And the last step to solve for y, get rid of that 5 times y by dividing by 5 on both sides. So we're going to get y equals negative 10x divided by 5. That does divide. That's going to be negative 2x. And 3 divided by 5 does not divide, so we're going to keep it as 3/5. Do not use decimals, all right? Keep it as fractions. And then negative 2x is going to, our slope is going to be negative 2. That's what's in front of the x. And our y-intercept is going to be 3/5, which is kind of weird, but you can have y-intercepts that cross at a fraction, so. All right, number 6, y equals negative 5. This one's kind of confusing. Well, this is Hoy Bucks, right? So Hoy, is this a horizontal or a vertical line? This is going to be a horizontal line with what kind of slope in Hoy? Horizontal, 0 slope. Our slope is going to be 0, and it's y equals, and a number is going to be the equation, right? So this one's going to be y equals, it's y equals mx plus b, but there is no x for this one, so it's going to be 0x minus 5. Y equals 0x minus 5. So our slope's going to be 0, our y-intercept is going to be negative 5. Okay, moving on. All right, how to graph using the slope and the y-intercept. So here's the steps. First thing you're going to do is you're going to solve the equation for y, get y by itself. All right. Then you're going to find the slope, which is m, and the y-intercept, which is b. All right. You're going to plot the y-intercepts, or b. And then we're going to use the slope, rise, or run to find other points on the line. Okay? So So we're going to start with some easier ones, and we'll work our way up to some harder ones, then we'll get into day 2 after that, okay? All right, so we have number 1 here. It says write the equation in slope-intercept form, then graph the equation. All right, is this one in slope-intercept form? Is y by itself? Y is by itself, so we can just rewrite the equation the way it is because it's in slope-intercept form. Y equals 2/3 x minus 4. What's our slope? Well, what's in front of x is 2/3. That's our slope. And then our b is going to be -4. So the steps say the first thing we're going to graph is our y-intercept or our b. So our y-intercept crosses the y-axis, okay? So where would -4 be on the y-axis? Well, it's going to be up 4 or down 4 are our only 2 options. We're going to go down 4 because it's -4. 1, 2, 3. This is our y-intercept. This is where we start. Okay, that's what the b means. It's literally our y-intercept. Now our slope is 2/3, which is rise over run. So we have a rise of 2 and a run of 3. So a rise of 2, is that up 2 or down 2? Well, it's going to be up 2, and then we're going to go, a run of 3 is always to the right, so we're going to go right 3. So up 2, right 3, 1, 2, 3. Up 2, right 3. Then we go up 2, right 3 again, up 2, 1, 2, 3. And we are out of room, but we still have room to the left. So instead of going up 2, right 3, we can go over here to the exact opposite direction, which would be down 2, left 3. And that way we can fill out the entire graph. Down 2, left 3 is going to fill out the entire graph. That was bad. And there's our graph. Dang it. Turn off that light. Okay. Number 2. We have 2x minus y equals -3. First things first, is y by itself. Is it in slope-intercept form? It is not. So we need to get y by itself. What would be the first step to getting y by itself? Well, I would subtract 2x from both sides. So we're going to get -y equals -2x minus 3. Now, is y by itself? Well, it kind of is, but we have that negative in front. We have a -1y. How do we get rid of that -1 in front of the y, the negative? We're going to divide both sides by -1. You could also multiply both sides by -1. You just got to make sure you multiply everything by -1. But I like to divide, makes it easier. So -2x divided by -1 is going to be positive 2x. And -3 divided by -1 is going to be positive 3. So that now we're in slope-intercept form. We got y by itself. Y equals 2x plus 3. All right, what is our slope? Well, our slope is 2, but I need to be able to see the rise over run. So is 2 the rise or the run? Well, I can rewrite 2 as a fraction. What's 2 as a fraction? Well, it's going to be 2 over 1, right? This is nice. This is our rise is 2, and our run is 1. That makes it easier to see. So make sure you rewrite whole numbers as fractions if you need to be able to visualize what the rise and run is going to be. Otherwise, if you just know that's going to be 2 over 1, you can do that as well. So our y-intercept is going to be the b, which is going to be 3. So where do we start? We have the 2 over 1 slope, and we have this y-intercept of 3. Which point do we graph first? We graph the 3 first. We graph the y-intercept first. So y-intercept on the y-axis right here. Are we going to go up 3 or down 3? Those are our only 2 options. It's positive 3, so we're actually going to go up 3 and put a point. That's our first point we graph with these kind of equations. All right, now we have a slope of 2, which is a rise of 2 and a run of 1. Is a rise of 2 up 2 or down 2? Well, it's going to be up 2, and a run of 1 means go right 1, and there is our second point. But with this, we ran out of room again. To make it a more accurate graph, we need to go the exact opposite direction. Instead of going up 2, right 1, we can go the exact opposite direction, which is down 2, left 1, right? So we can go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. And there's our graph. All right. Next thing we have, now we have 3y minus 4x equals 9. Let's change the colors here. So we need to get y by itself again. Is y by itself right now or no? It is not by itself. So what should we get rid of first, the 3 or the -4x? Well, usually we don't do multiplication first. Usually we get rid of addition or subtraction first. So I'm going to do, instead of subtracting 4x, I'm going to add 4x to both sides. So I get 3y equals 4x plus 9. Okay. Now we need to get rid of that 3 in front of the y. We're going to divide both sides by 3. So we're going to get y equals, does 4 divide by 3 nicely or no? It doesn't, so we're just going to write 4 thirds x. And then what's 9 divided by 3? That is 3. Now we have y by itself, so we can write our slope-intercept form. 4 thirds x plus 3. So our slope is 4 thirds, which is nice to see the rise of a run with, and our b is going to be 3. So are we going to go up 3 or down 3 or with our y-intercept? It's positive 3, so we're going to go up 3 on the y-axis and put a point. And our slope is a rise of 4 and a run of 3. So we need to go up 4, right 3, up 1, 2, 3, 4, 1, 2, 3. So you can do this if you want, but it's off the graph. Instead of going up 4, right 3, it might be easier to go down 4, left 3. Then go down 4, left 3. And there's our graph. All right, number 4, and then we gotta move on to the last section of the day here. 3x plus y equals 0. Is y by itself in slope-intercept form? It is not, so we need to get rid of that 3x. How do we get rid of that 3x? Well, we subtract 3x from both sides. I forgot to mention this 9 and 4x do not combine. They are not like terms. 9 does not have an x, so just be careful with that. So now we have, the 3x's are going to cancel. We get y equals negative 3x. I'm going to put a plus 0 here for now, because if it's just y equals, it could also just rewrite it as y equals negative 3x, and then your b is going to be 0, but sometimes it helps to visualize that. So let's write them both. Let's write y equals negative 3x, or y equals negative 3x plus 0. So our y-intercept is going to be 0. Slope is negative 3, which equals negative 3 over 1, right? You can write it as a fraction. All right. So where do we start? It's a y-intercept of 0. Where do we start for that one? Well, we're going to start at the origin. We're going to put a point right here in the middle at the origin. Our slope is negative 3, so we're going to go down 3, right 1. Down 3, right 1. We can also go the exact opposite direction and go up 3, left 1. Up 3, left 1. Change this. Not perfect, but you get the idea. Okay, and that's how you graph lines using slope and y-intercept. All right, last section for today, and this one hopefully will be not too fast here, or not too slow here. Parallel lines and slope. What is the relationship between parallel lines? How can we tell if two equations of lines are going to be parallel? So parallel lines are two distinct lines in the same plane that never intersect. That what? That never intersect. It says in the graph at the right, there are two lines, AB and MN are parallel. Find the slope of each line. So this is actually should be, it says MN, this is the P right here. This should actually be an N right here. Okay, so just keep that in mind. That point's going to be an N. So let's just calculate the slope and see what we get here. So I'm going to do A to B. Let's calculate the slope of A to B. So from A to B, we're going to go up 3, it looks like. We're going to go right 1, 2, 3, 4, 5. So our slope of AB is going to be 3 over 5. Now, these are parallel lines. Let's see what MN is going to look like. I bet you can kind of see already what it's going to be, but let's give it a try. So for M to N, we're going to go up 3 again. Dang it. Up 3. We're going to go right 5. So again, we have 3/5. So it looks like the trick of parallel lines is their slopes are, we're going to put are the same. Slopes of parallel lines are the same. Okay? So parallel lines and their slopes, if two lines are parallel, then they will have the same slope. Okay? And here's some parallel symbols here, in case you see parallel lines. Parallel symbols are two vertical lines or two kind of slanted lines like this. That's bad. Okay, those are parallel symbols. So all we have to do to determine if two lines are parallel is we need to compare the two lines in slope-intercept form and see what these slopes are going to be. So let's go ahead and do that. Well, number one, we have y equals 2x plus 3 and y minus 2x equals negative 7. Well, the top equation is y equals mx plus b. Our slope is going to be 2, which is nice, but the bottom one is not solved for y. So how do we solve for y in the bottom? Well, we're going to add 2x to both sides. We're going to get y equals 2x minus 7. Well, what's the slope of that line now that we have it by itself? Well, it's also going to be 2. So are these parallel lines or no? These are parallel, and the reason why is they have the same slope. That's all you got to do. Okay? Number 2, we have 2y plus 3x equals 5, and we have 2y equals 3x plus 8. We need to get y by itself for both of these problems. Let's go ahead and write the top one the way it is originally. All right, what's the first step to getting y by itself over here? Well, we're going to subtract 3x first. So we get 2y equals negative 3x plus 5. Divide by 2. Y equals negative 3 over 2x plus 5 halves. So the slope for this one's going to be what? It's going to be negative 3 halves. And this one over here, we have 2y equals 3x plus 8. We got to divide by 2 on both sides. We get y equals 3 over 2x. And 8 divided by 2 is 4. Slope of this one is 3 halves. Are these the same slope? At first glance, it's yes, but what's the difference between these two? Well, one is a negative. So this is not parallel, even though they look similar. Not same exact slope. And that's our final answer. Okay, so it's easy as that. For them to be parallel, you just got to make sure you can compare the slopes and write them in slope-intercept form. And yeah, that's all you got to do. Thank you for watching. Have a great day. We will see you soon.